Okay, dear students, this is question about the resistivity and the resistivity. Okay, so we have the thickness of this semiconductor wafer and the length of this semiconductor wafer is given. So we need to find that the rho is equal to VT square over RT, where rho is the resistivity. We have to prove this rho is equal to VL square over RT. Okay, in order to prove this rho is equal to VL square over IT, let me describe the figure first. So for example, this is a semiconductor wafer in which the wires are connected. Here wire is passed through this semiconductor wafer, and as long as the wire is passing through this kind of semiconductor wafer, so the current passes through that kind of material. So it means for the current to pass through, this thickness is actually this thickness T is actually the length for the to pass through this wafer. Okay, in order to find the resistivity, because in this question we need to find the resistivity. Okay, so resistivity is the specific resistance. Okay, so in order to find the resistivity, we first know that the resistivity equal to rho is equal to, so first we derive the formula for resistivity. As we know that resistance is defined as rho L over A, and where we can find resistivity rho is equal to R multiplied by A over L. Okay, so this is equation number 1. Okay, so in the part 1 we have to prove that rho is equal to VL square over IT. So in order to prove this, first we need to remind that the A is area of a wafer or the semiconductor material. So area is, you know that the area is this length multiplied with the width. Both are L, capital L. Length and width are both are capital L. This one. So actually we can see that length L and width L, so L square. So area is L square. Area L square. Now for this length, as we know that the when the current passes through these wires, so for the current, this thickness is actually length or distance covered by the particles or by the electrons. So it means the thickness T is actually the length for the material, this kind, because we know that these two sides makes area, this side and this side they makes area. So this T thickness is actually the third side, that is the L, that is the length. Okay, so in the formula this length is actually the thickness. So length L equal to the thickness, because we know that the current is going through this thickness, so length is equal to T, thickness T. Instead of L we use T because the current is going to pass through this thickness. Okay, T. So we just replace rho is equal to R A. Area is L square, as we know the area is L square, and the length is the thickness T. So if we use Ohm's law, so R is equal to V over I, because V is equal to IR and R is equal to V over I. So we replace R with V over I, so rho is equal to V L square over IT. So this is what we need to prove in part A. This one, R is equal to VL square over IT. Okay, in order to find the resistivity rho of the semiconductor, so rho is equal to, we use this above formula VL square over IT, because we have all the values. The V is the voltage or potential difference that is given in this question, that is equal to 0.13 volt. Current is 32 milliampere, and we know that the thickness is, length is given 25, value the L is given 25, and the thickness is 0.60. so we put all the values and we get the answer. So V is the voltage, that is 0.13 volts. Length is L is 25 into 10 power minus 3 meter square, millimeter is 10 power minus 3, and current is 32 into 10 power minus 3 ampere, and thickness is 0.60 into 10 to the power minus 3 and we just put an values and we get 4.2 ohm meter. So this resistivity is the in ohm meter. Okay, so this is question where we have only the value of the this length and this thickness is given, so we can find the resistivity by using this equation. Rho is equal to VL square over RT. Okay, thank you.